This is the Open Metaverse Browser Initiative BOF here at SIGGRAPH 2026, so thank you all for coming. My name is Neil Trevett. I'm the president of the Metaverse Standards Forum and the Khronos Group, and we have Dean and Yin-Chien here from RP1, and we're going to walk you through the problems that the Open Metaverse Browser Initiative is trying to solve and the solutions that we're proposing to bring spatial computing to the web. And the metaverse is rather a loaded term. It's gone through lots of bad PR, so we're taking care to use metaverse in this session in a positive way. The terminology that we're using, and I think is becoming more widely adopted in general, is nested terms: XR, spatial computing, metaverse. They often get confused and mixed up. The way we're using it, XR is using devices, AR or VR devices. Spatial computing is when you use those XR devices to understand and interact with the environment around you. And then the metaverse is when you have multiple people using spatial computing, also connected to services and AI of various shapes and sizes. It's not the dystopian vision of the metaverse of people sitting in VR for 16 hours a day, disconnected from their friends and family. AR brings people into the world, and smart glasses is the way. So this session is being hosted by the Metaverse Standards Forum. I want to spend one slide explaining who the forum is, if you haven't come across us before. Despite having standards in the name, we're not a standards organization. We are an organization that exists to enable multiple standards organizations who are creating standards to come and communicate and cooperate together to build the interoperability around open standards that we need to build this platform that we're calling the Metaverse. So when Meta announced their Metaverse initiative back in 2021, it became quickly apparent that we were going to need a lot of standards, a constellation of standards from many different standards organizations. And yet there was no one place for those organizations to come and talk to each other. It's not just 3D standards, it's geospatial standards, networking standards, web standards. They all need to work together to create this platform. So, but if we're not a standards organization, what do? We try to help standards organizations by giving them visibility and feedback, pre-standardization, generating use cases and requirements, post-standardization, test beds, and feedback on standards after they ship. Are they fit for purpose? Are they actually solving industry needs? We have about 2,500 plus members. We launched in 2022. And it's open to anybody. And the entry level is free. So if this is of interest to you, please consider joining the forum and getting involved. The way that the forum is organized, we have a board like any non-profit organization. We have 4 working groups that focus on key domains that are relevant to the metaverse: 3D assets, spatial computing, infrastructure, which is mainly around the infrastructure concerning decentralized identity and economy, and then ecosystem and governance, where we talk about governance, how it affects the technology. We have this new vehicle for activities which is called initiatives, which is what we're calling the projects that we have that involve significant open source. The Open Metaverse Browser Initiative is the first, but we hope it's the first of many. The way that the initiatives are organized is the open source project sits outside the forum. You don't have to be a member to participate and contribute to the open source. But then we link the open source project back into the forum through a business council, which is where the prime promoters and contributors from a business perspective can get involved in the project. And then we link all the work that the open source project is doing back into the working groups, because we need the input from the working groups for many of these tricky issues, and in many cases the open source projects can be a test bed for the activities that the domain groups are undertaking. So, what are we trying to do here? So, the world is going spatial. That's the basic proposal here. The hardware devices are evolving. Every era in computing has its defining hardware platforms, from PCs to phones, and now we're getting these XR spatial capable devices. PCs and phones are not going away, but these new generation of devices have new capabilities that the older devices don't. And that means we can elevate the user experience from text windows to the World Wide Web, which works, of course, on your PC or on your phone. But if you're wandering around in the real world, looking at the web on your phone, you have to avoid the walking into lamppost syndrome. But now with the new smart glasses, we can enable users to walk around in the real world in a productive way, and we need to lift the user experience to enable and bring the full value of these new generation of devices to users, and this is a process that's ongoing right now. The engine for bringing spatial computing into the consumer and enterprise space are the smart glasses. Smart glasses aren't the only platform that will support everything we're going to be talking about. It will run on mobile phones, it will run on your PC, but the best experience we think is with the AR smart glasses, and of course there's a whole range of manufacturers that are bringing these smart devices to market. Everyone is going to benefit if we can build a strong software ecosystem that feeds into the devices that are being built. So if we have a lot of devices out there over the next few years, AR, VR devices, mobile phones, we need a global platform to deliver useful information and services to those devices. But it's not just humans. AI, embodied AI, physical AI, autonomous vehicles of various shapes and sizes are also going to be interested to access the information and services if those services become easily discoverable and available for use. I think there's going to be a whole range of services on the individual level, smart homes, IoT, controlling your environment at a personal level, digital twins at the enterprise level, and then at the municipal level, smart cities, traffic routing, citizen services. There's really opportunity for new classes of services at every level of society. And that means that these devices need to be sensible to the services that are around them, be able to discover when they become available due to your position in the world, and discover those services and connect to it. So we need the platform. The only platform really that has the global reach and is already based on open standards is the web. So I think there are many folks that would agree that the metaverse is going to be the spatial evolution of the web. So we're looking to build out the web to include this new spatial infrastructure. It's kind of interesting to consider what we say services. It's pretty abstract. So what are some examples of services that might be of interest? And how do those new spatial services compare to the current services that we enjoy on the existing web? So we put together some examples here. So video call, Zoom. Hands up here, who's used Zoom? No, just kidding. The video call does 2D images. We want ideally remote presence, so mixing AR and VR devices to enable much more interactive and compelling co-presence. And we have some examples of that later. But even more everyday activities, walking through an airport rather than looking at the floor plan on the wall, actually having spatial devices that guide you through the airport interactively with different services and facilities being presented to you as you walk through the airport. And at the bottom, more enterprise example. If you have people on the warehouse floor with smart devices, they're going to be able to be fed not just 2D sheets of information that you could have got on a spreadsheet, but spatially mapped information around different incidents or areas of interest on the shop floor, on the warehouse floor, all in real time. The devices connecting to these services that are providing the 3D assets and the information in real time to the user. If we can make this concept take off, if we can build the standards-based infrastructure to enable these devices to find these services in a meaningful way, you can see that potentially the software ecosystem could easily take off in the same way that the web took off for 2D. And just like there are millions of web pages, the vision and the hope is that there would be millions of these spatial services. And that web of services around us at all times would essentially create the core of the metaverse. So you can see the examples, the airport example that we were using before in manufacturing. Again, not just having 2D windows floating in space. It's much more useful if you can locate the information using the imaging capabilities, the spatial registration of these XR devices to actually pin useful data to the real world scene around you. I mean, there's going to be inferencing and image processing, all kinds of good processing to make that happen. But AI is making a lot of this stuff that was magical only a year or two ago, is making it quite feasible nowadays. In the enterprise space, guided task, remote expert, these kinds of activities become enabled. A lot of enterprises have been wanting to ship that kind of app for a long time, but we'll see in a moment that there's really real blockers to enterprises shipping that we hope this initiative will help unblock. Smart cities, people going through environment navigation, finding services, recommendations, and education too, having remote participation in education, having services to provide engaging educational experiences. So we have a video, just a couple minutes. So this is kind of hopefully illustrating some of the ideas that we were just trying to, I was poorly trying to explain. So walking through an environment, services get loaded as you walk up to them. You can have services from multiple providers in one scene. So there's a restaurant reviews, there's a navigation service, and there's a ride service. They're all being composited into the scene around the user in real time. There's spatial registration to identify the vehicle that is yours. This is a more enterprise example. So as the user wanders around the facility, the services respond to where he is. It goes into this aisle. The information around the products come up automatically. This is perhaps the pinnacle, the the long-term hope of that we can achieve something like this, a mix of AR glasses and VR devices. So the AR glasses are projecting that kind of hologram in their display, and the remote person is using VR. And you might say, well, how is the VR person seeing the room? Well, it's a digital twin. I can see a future where normal people at home will Gaussian splat scan their living room, load that 3D digital twin onto their home Wi-Fi server, and when they choose, they can enable the people that dial in to their home to actually enjoy the digital twin with them located with their devices, doing the necessary facial and gesture animation and sending an avatar stream to the remote person in VR and vice versa. There's a lot, obviously, it's a vision, but you can see the pieces beginning to come into place. So, hopefully that kind of sets some of the scenes of what we want to achieve. I'm going to hand over to Yin-Chien, who's going to have some more specific examples on use cases.
Thank you, Neil. We have talked in the abstract about a number of these things, and we thought it would be useful to look at an example of the imagined future when the metaverse does exist, as we hope. And the metaverse, in my mind, is a combination of multiple spatial services. It's a single open ecosystem for augmented and immersive solutions and experiences, much in the same way that the web is an open ecosystem of essentially 2D information. So to choose a location into which we could imagine this metaverse, we've chosen a theme park. For no reason, we're in LA, there's no reason why I chose a theme park. And we've specified a number of zones in which metaverse services, applications, experiences might occur. There is a welcome zone, a dining zone, a work zone, an adventure zone, and most importantly, an admin zone, because everything happens in back office. So in the first instance, we can imagine a metaverse application or location or service where it is an AI-powered greeter avatar. And it allows the organization to welcome park visitors and show them the routes to requested destinations. What's important in this visualization is that services for delivering the greeter service, which is anchored in space by where that little hand is standing, the appearance of the avatar can come from one service. The AI for communicating with the understanding what the visitor is saying to them can be from a second service, and then the speech synthesis can be from a third service, and it then connect to a fourth service that actually does the route finding and does the route visualization. The concurrency of these services is a feature of the metaverse, which is currently hard to achieve with the web. Secondly, it's a category of location-aware information on demand. The idea is that as you go through a space, your phone does have the menu of all the eating facilities on the site, but with location awareness, that information appears when you are close. So you can design your menu, and it will only appear when somebody is close to the eating location. Now, in addition to just static information like that, because of the combination of services, it is possible for the menu that is presented to you to be filtered with what is your eating requirements, what are your dietary requirements, so that although there is a raw, unfiltered feed that comes to your headset or your smart glasses, based on your personal information, it can filter it down to the list that is personalized to you. So the idea of personalized information based on location is one of the powers of the system. It's also seen here that because it's location-based, competition can be also allowed to happen. So a second restaurant might also be putting up its menu outside its space. So you're not tied into one information source as you wander around. The thing that determines what you see is where you are. Metaverse services can also be used for less consumer-facing situations. Here we have demonstrating object spatial tracking for guided repairs. Defect can be seen by somebody, and they will take a picture on their phone, which will be linked to a VPS and a repair system, so that when the worker comes to do the repair, they are able to identify exactly where it is and for it to log back into the repair system. these sort of productivity gains come from being able to combine services from various sources, and you can change vendors according to what you need to achieve. You're not tied into one thing, because the metaverse is open, like the web is open, and you can combine things together as you need them. And at the top end of co-presence, which Neil has already mentioned before, is the idea of having immersive and embodied entertainment experiences or training experiences for both local and remote participants. It is hard to tell that this isn't just a VR shoot 'em up. It essentially is. It is a VR shoot 'em up. But the idea with in this particular scene is that besides the VR users who are on site at the theme park, it's also possible to link into participants who are remote. Shared spaces, which are hybrid co-presence, where there are remote and local players participating in the same area. Also to show that with combined and shared services, it's possible for the location to be provided by a location provider, for the game logic to come from a second provider, and for the map system to come from a third provider. So it is, again, a demonstration of mixed services. And also to show that the metaverse isn't just for XR devices. Here is, with the open standards, it will be possible to make interoperable content creation tools. Here we have the service installation map, essentially, and somebody is being able to put services like route finding or food recommendations onto the map with a drag and drop system. And the directory system will be one service that can be linked into the metaverse, and the map display is a second service, and it is running on a flat screen device and still taps into the same infrastructure as before. So in all these cases, different providers of scripts, behaviors, and apps, content like images and 3D files, are able to share into an ecosystem, host it themselves, and be able for it to be provided based on location. So you're not tied in one platform, you're not tied in one place. You have choice, you have options, and you can contribute to it in the way that the web has told us is possible. And we are wanting the metaverse to be able to do that for spatial experiences as well.
Cool, thank you, Yin-Chien. So that all sounds great, but why can't we do it? Why aren't people doing it right now, today? So the web was not designed for this kind of spatial browsing. We do have WebXR, and we love WebXR. This is not an anti-WebXR initiative. We think WebXR has definite use cases. If people want to code an immersive app, they need just data from a single origin. They want total control over the programming stack. Then WebXR is awesome and will continue to be awesome. But the WebXR has limits because it's working within the current web stack. And the listed here, the key one is that it's not easy for a single WebXR app to easily and dynamically connect to multiple discovered new services. You can imagine a WebXR app that's been programmed to try and discover and understand new services that it's allowed to connect to. But if there are millions of services out there, it's just not possible to have a single app that can know how to use and connect to such a diversity of different services. There needs to be a more seamless discovery and connection stack and protocols in place. Also, the current web stack is not built for proximity-based detection of services. Obviously, the typical way is you type in a URL or click on a link. There's no infrastructure in place that's widely adopted to enable users to wander the real world, discover what services are close to them, connect to them, understand them, and deploy them on a device. And perhaps the most significant and fundamental thing, which is by design in the current web, it's not easy to handle multi-origin sources of data. This is the fundamental security model of the web, is you don't allow cross-origin access to data unless it's under very strictly controlled circumstances. Where we have shown in some of those examples is that you will have ideally dozens or even hundreds of services being offered to you, and you need a way to present them all to the user, if the user elects to turn them on, in a single scene being presented to the user. There's no simple way to do that in the current web stack. And all these things, again, are kind of lighthouse use case is co-presence. All these things means you're not going to be able to do really advanced spatial applications like that that are geolocated. And that, I think, is to a large extent it explains the current state of the metaverse software ecosystem. Basically, there isn't one, because everyone is having to build walled gardens. Very large, of course there are many reasons, but I think this is a large part of why we're just not seeing the metaverse software ecosystem take off. We've talked to many enterprises. They want to deploy spatial services. In many cases, they have prototyped spatial services using WebXR on HoloLens, but they just can't deploy them because of these issues. That means we've ended up in a situation where the hardware and the software are vertically siloed. We're in the AOL CompuServe phase of the metaverse. And interesting, doing this, I actually discovered, I've forgotten, back in the AOL phase, if you were an AOL user, you couldn't email a CompuServe user because the email systems were incompatible. That was the level of walled garden. I can't believe that was true, but it's true. And we're in kind of that phase right now. And of course, as soon as an open standard appeared for standardized email, that will disappear. Standards are the key to solving this problem. But because people are in walled gardens, there's no positive network effect. People can't leverage and build on the work of others. Everyone is trapped within their own silo. Everyone is having to build their own tools and content. And it means that people just aren't able to build the spatial content that we can imagine. Also, having walled gardens presents another critical point of failure that's preventing enterprises from shipping spatial capabilities. All of these companies here that we mentioned were all awesome. Each of these products and companies were doing great work, but then the commercial reality shifted for whatever reason, and they just got pulled. And that decision to cease the product or the service was under the control of a single company. There was no backup plan. There was no way to keep those services going. So people using these products or services deploying were left literally in the lurch. Content developers that have invested in content running on these platforms had nowhere to run their content. Again, this is a problem that can be solved, of course, with open standards, which is why the web is the right way to go. A single point of potential failure is just not acceptable to many enterprises. And in fact, there are quite a few non-negotiables for enterprise customers. We think that probably the enterprise space will be the beachhead for the kinds of services we're talking about, because as the hardware begins to ship, it will not immediately be accessible in price point probably to every consumer. It's going to be the enterprise that gets return on investment first, and of course that will drive up volume, drive down cost, and eventually it'll get to consumers too. So as we try to figure out how to make this vision come true, it's important that the enterprise customers are enabled. And through talking to many enterprise potential deployers of this technology, we've come down to realize there are kind of 5 non-negotiables. If we can't tick off each of these 5, we're going to continue to see basically non-shipment of the metaverse. The interoperability, we've already talked about. You've got to be able to ship content into any standards conformant browser on any capable XR device. So if one vendor decides to discontinue the device, it's no problem. You just can run it on any other conformant device. One of the really important things, and it comes back to the multi-origin question, that enterprises do not want to share all of their proprietary data. Although you could imagine a platform or an application that's trying to understand more and more services, it means that the provider of the data has to route their data onto that application or platform. And that's different to the 2D web. You don't have to do that on the current 2D web. There's no way to do it spatially. Frictionless access. So again, everything working together, and an open developer system where everyone can develop tools and applications to run on the platform. So we come down to a requirements list, kind of repeating what we just said, but in terms of requirements, enterprises need self-hosted spatial content without having to go through a third party. They want to publish their 3D spatial content as easily as they publish a 2D website today. We need proximity-based scene loading. We need highly secure way of getting data from multiple origin sources. It's no use if it's not completely secure. We need seamless service integration, where as you wander through the world, these services are being loaded and unloaded when you walk away from them. And all of this, again, is working towards this pinnacle use case of spatial co-presence. So that's the requirements. That sounds like an easy job. So, job for Dean.
And you're hoping I'm going to solve them? Holy mackerel. Give me the tough work. So we are solving them. We are in active development of a couple products right now. Under the OMBI, we're building a Metaverse Browser Engine called Sneeze. And if you're not familiar with what a browser engine is, you've all interacted with them. Web browsers have 3 primary browser engines right now: Blink, WebKit, and Gecko. They're found predominantly in the most popular web browsers that everyone uses today. So the job of a web browser engine is to take the HTML, CSS, and JavaScript that it receives and turn them into a viewable, interactive web page. So you have the browser, which is the application that is built around the browser engine. And it's the browser engine's job to take the core components of what it receives over the internet, turn them into a web page. The Metaverse Browser Engine does the same thing, but it does it with spatial content instead of 2-dimensional web content. The browser engine's job is to take the GLTF, to take the browsing programs, to build up the scene, to handle all the different components and put them in a small package so that it could be either put inside of an existing, we won't even call it a web browser anymore, we'll just call it a plain old browser, right? So you could take Chrome, Firefox, or Safari and put Sneeze inside of it, and if you go to a web page, or if you go to a URL that ends in MSF, stands for Metaverse Spatial Fabric, it would load up the Metaverse Browser Engine instead of the web browser engine. You could also take that engine and embed it directly onto XR devices, like a pair of glasses. So you can imagine putting on a pair of glasses and having it boot up directly into a Metaverse browser, and you just wander the world wearing your glasses that interact with the world through the browser engine. And thirdly, you could put it inside of a standalone, dedicated Metaverse browser. And I'll be demonstrating one of those at the end of my segment here. One of the most important things on this page is at the very bottom. This is all open source. Apache 2.0. So you can download it right now. You can go to our the GitHub repository. You can look at it, tinker with it, contribute to it. So this is all done for the betterment of mankind. So we hope everyone participates. If it wasn't open, I don't think we'd get the buy-in that the industry needs. So what does a Metaverse Browser Engine actually provide? There's a number of things that a Metaverse Browser Engine provides that a web browser doesn't. Because if it didn't provide something, then we would just be using the web browser engine. In no particular order, but probably the most important is multi-origin scene composition. So one of the key critical differences between a web browser and a Metaverse browser is web browsers are inherently single origin. Your web browser goes to a single web page. That page gets full control of the rectangle. In a Metaverse browser, you are browsing where you are, whatever happens to be around you. And if whatever happens to be around you is coming from multiple origins, then so be it. They all get to participate in the scene equally. It's the browser's job to coordinate bringing in different content from different publishers, putting them into the scene, and having them fall out of the scene as you move away. But no one publisher gets to own the entire Metaverse browser at any one time. And as you just mentioned, it's all based on proximity. So wherever you go, we're here in a convention. As you walk around the convention center, lots of different things are going on. Wherever you are in the world, wherever you happen to be, that's where you are. And whatever content is there, that's what makes it into the Metaverse browser. So it's very different than a web browser where you're browsing what I call random access. You pick and choose, depending on your mood or your needs, where you go based on what URL you type into the URL line or what you click on. You can go anywhere, but there's no coordinate system in a web browser. Amazon is not next to Yahoo. They're just in different unspecified locations, whereas within a Metaverse browser, it is spatial by nature, so everything has a coordinate position, either here on Earth or imaginary out in outer space, size of the universe. I won't take forever, but you can look at the chart here. We have the concept decentralized identity. So the Metaverse browser will handle an identity for you. It will broker that identity to the different services as you walk around the world so that you don't have to stop every 10 feet and create a new account, right? That would be awful walking through any public location, having all these services interact with, but to do so, you have to create a brand new account, give them your email address, sign up a password, and all that. That would be nearly impossible. And I'm going to talk about some of these other ones as we go. So we'll move along. Here are the innovations that we've contributed to making a Metaverse browser actually work for the Metaverse. The scene object model is very comparable to the DOM. So if you're familiar, if you've ever opened up, hit F12 and looked at the inspector, you can actually look at what the DOM looks like. DOM is your document object model. SOM is your scene object model. So the scene object model is a standard 3D scene graph. It organizes all of your objects in your space three-dimensionally. Every parent's got multiple children, or I should say every child has a parent. It provides a relative coordinate system that gives the commands to the graphics card to actually draw the scene. It is built up through a combination of mapping that is acquired from the browser directly to map services or from services that can contribute to the SOM and can interrogate the SOM for what's around it. The great thing that the browser does, like I mentioned earlier, it's multi-origin. So the browser's job is to portion out the SOM to the different applications, the different services, the different publishers that all share it. We have a concept called spatial fabrics, which you could think of as a new version of a website. It is a way of mapping content and services into a scene, into a coordinate space, and all of these independent spatial fabrics by publishers are put into the SOM. And so the spatial fabric directs the browser for the spatial anchoring and tells you what is where within the space. So within this convention center or a location like an airport, the airport would publish a spatial fabric, or the convention center would publish a spatial fabric that would tell you where the services all around the area. I want to highlight one of the coolest things for any web programmer out there is we will not be adopting the model of cores and domain-based security. So right now, one of the what I believe, personally believe, is that one of the most awkward interactions between a website and a web browser is the security model based solely on the domain name of the URL that you've put into the web browser. So instead, we're swapping that out for a certificate-based security where your spatial fabrics are signed, they're given to a known publisher, and we can use that information specifically to control the security and sharing of information between services that are around you. Lastly, I will touch on RMAP, which is a brand new standard that we hope that everyone will embrace. It is an ideal way, based on our experience, to run real-time services. They don't have to be real-time, but it works optimally for real-time, and it allows the browser to broker information between a service and between the remote server and the service that's running on the client in a really optimized way. RMAP stands for Remote Model Access Protocol, and I will talk about that a little bit more later on. Any question that people ask me about the metaverse can I'd say just about always be answered with an analogy to the web. So all the concepts that we're introducing here are actually concepts that you're probably familiar with. We're not reinventing the wheel. Yes, there are some brand new ideas in here, but they relate very closely to things that you're already familiar with on the web. Web servers have metaverse servers. Websites are equivalent to spatial fabrics, and on and on. I'm going to be talking about and highlighting spatial fabrics in a moment. But we are using as many of the existing protocols and standards that are available on the web. We might be adding one or two more that are really cool, trust me. But there's a very, very, very large analogy between the web and the metaverse. So we will have a Q&A session afterwards. If you ask me a question about the metaverse, I will probably draw an analogy to the web. So let's talk about spatial fabrics for a moment. Spatial fabrics is the way that you organize information, similar to the way that you would build a website. So a website has a HTML document as a controlling document, and it will direct the browser to pull in additional CSS content and additional JavaScript content, and then the JavaScript will manipulate the page over time and either slightly change it or radically change it, depending on how aggressive the JavaScript in the website wants to be. Spatial fabrics, similarly, are containers of information that direct the browser where to find things like the map and where to find things like the running WASM programs that comprise that particular coordinate space. So a spatial fabric, as we define it specifically, is a mapped coordinate space containing content and services. And I want to highlight two things. Number one is we're way overloading the term services to mean just about any running program that you'd find within the metaverse. But in particular, we believe that the metaverse will be inundated with services. That's one of the great features of the metaverse versus the web. So wherever you go, the services are your interaction point. It's what allows you to, when you walk through an airport, when you walk into a hotel or walk into a retail store, allow you to direct you to the product you're trying to find, direct you to your gate, direct you to helping you find the dog food in Costco. Whatever it is that you're looking for, services are going to be very, very prevalent in the future. And specifically, AI services will most likely find a very, very, very nice home in the metaverse. So here's a particular example that we're highlighting. An airport is like a little city. We've actually been talking to some airports that are already digital twinning. They're already trying to create a spatial environment. And there's some very particular problems that they have that are in the real world. The airports run a facility. They're very, very large facilities. They generally have one or more terminals. Those terminals are occupied by airlines. And the airlines and the terminal owners or the airport owners do not always want to share information. And so the great thing about the metaverse is it allows a space to be portioned out and have more than one occupant in it, right? It's multi-origin. So you can have an airline occupy a particular portion of a terminal underneath the airport owner, And the airport owner can also give access to restaurants and vendors, storefronts. Anything that's within that space can be portioned out. And if you're walking through the terminal with a pair of glasses on, you will be able to interact with all of them at the same time. And each owner of each spatial fabric gets to keep their own content. They get to run their own content in their own way that's good for their own business. And all this gets composed together in the Metaverse browser, and it presents a cohesive view for the end user who's walking around in that metaverse. And it is all proximity based. So wherever you're going within the terminal, as you move from the entry point through the check-in to your through security, through the gate, all the services that you're going to be presented with will be based on where you are within that airport, and that's dictated by the map provided by the spatial fabric. I've been saying services a lot, so as you go around the airport, again, all these embedded services, and there could be third-party services in here, they all come together. And one thing you'll find is the whole journey, from the time you leave your home to the time you go through the airport, into the air, land at the other airport, no installs whatsoever. Everything is brought to you through the browser, because that's what browsers do. They pick up the content, they deliver it to you safely and securely, and you don't have to worry about installing a piece of software on your device that you're not familiar with, because the browser sandboxes it and keeps it safe. Remote model access protocol is going to be integral in helping services get the information. There's a lot of words on this page. There's a lot of different information. I'm not going to go through the entire diagram. I will say from a high-level overview, RMAP is not a new protocol in itself, despite having the word protocol in its name. It uses underlying protocols that you're already familiar with, so it can use REST, it can use Socket.io, it can use a binary protocol. Any protocol that exists or that you want to invent can be used, and RMAP will basically piggyback on top of it. The great thing about what it really accomplishes, it puts the onus of the work on the service provider to deliver the software and the information all the way to the client side. So normally the way that a service provider works is they have a server running in the cloud, they give you a document with the specification, you take that document, give it to your AI agent, Claude will then read the document and write a piece of software for you that then will install on your client or ship with your particular product. But if a service vendor has 100,000 different customers, then that service provider has 100,000 different pieces of software written by 100,000 different companies that are all pretty much doing exactly the same thing. And so what RMAP does is it puts the onus of the work of providing that solution on the service provider so that they produce something called a model, and that model will run client-side within the browser and make it really, really, really super easy to consume. And so as a developer, you don't even have to know what the protocol is. You don't have to know anything about how the information moves back and forth. The way that you interrogate your model is the same for every single model. And it just speeds it up. It saves trillions, billions of hours to trillions of hours worth of development for developer time. So we'll have more information on RMAP very shortly. But RMAP, literally today, we are building it into Sneeze. And it should be working within a week or two. So here's what it ends up looking like. You have got multiple services that are running all at the same time. Neil showed a video of this working earlier. You have 3 different services that are coming from 3 completely different vendors that are all being composed into the SOM. You've got TripAdvisor giving you reviews for the Japanese restaurant to your left. You've got Google Maps that's helping you find your way within the street. And then you've got Uber, who's you've scheduled the Uber ride, and the Uber shows you that they've arrived. And so now all 3 of these work their way into the SOM. The browser puts all of them together, and you get one pre-composed scene. The SOM, I will tell you a couple of specific properties about the SOM. The browser's job, obviously there's a security component in here if we're going to let multiple origins share the scene. The browser has to have a way of isolating them or keeping private information private. There are public areas, so when you are a spatial fabric or a service, you can designate your portion or a portion of your portion of the SOM as private if you choose. A good example is if you're playing a game. I come from a poker background, so in poker, it's pretty integral to the game that your opponents can't see your cards. So within the scene, within my poker table, I'm going to keep my cards private, but there are public cards, there's chips on the table, there's other information on the table, all that is public. So anything that you want to allow other services to see and interact with, you can. Anything that you don't want to allow services to other services that are not yours to interact with, you can also protect that as well. And so you get a standard scene graph, parent-child relationship. Every fabric gets their position within the scene. They can overlap in space. Okay, so they are independent graphs or subgraphs of the tree, but there's no fixed rectangle. There's no box that you're stuck in. And so if you have two surfaces that occupy the same space or overlap or reach over into each other, that's perfectly fine. Here's another video. This is an interesting concept. This is a demonstration of a company called Patched Reality. They have a product called Fluxtent, and this is a service that they're offering. They have the ability to pick out on a map, they pick out an area in the real world. You can give it to their AI agent who will then mark it and build it for you, all automated. And so the great thing about having an open metaverse is you can have third-party companies develop tools. You don't have to wait for one company to build all of your tools for you. Another way to look at it is if you're a developer, you can now build tools for an open environment that anyone can use. So you're no longer expecting hospitals, say, to design all their own proprietary software, or a hospital doesn't have to sit around waiting for a closed ecosystem to build all their software for them. And so this is a company that has embraced this concept, and they are a tool provider who is the first within the industry, and they are taking the lead, and we expect many, many, many other service providers to come in and provide tools throughout the industry. So, putting this all together, we are, or have just launched a Metaverse browser called Artemis. I want to warn you, I want to say a caveat, at least today, if you're for today, Artemis is fairly limited, and because Artemis is developed so that we can develop Sneeze. Sneeze is a Metaverse Browser Engine, and it's very hard to develop a Metaverse Browser Engine without a Metaverse browser. And so Artemis is the product that we're using. You can follow along at home. It's downloadable. You can actually see what it is that we're building. I won't say as we build it, but as we do our regular, say, weekly releases, you can start using it. It will be fairly programmable. It's already programmable. You can build WASM programs. You can build spatial fabrics, but within a couple of weeks, you will be able to do some really, really super exciting, not that exciting thing. You'll be able to do some things with it. And as time goes on, I'd say by middle of October, that's our target because there's a big conference coming up, it will be highly usable. And I'm going to give you a little demo of it. This is Artemis. It's very small, so it downloads and installs very, very quickly. You'll notice a familiarity of a browser does not have the billions of hours that say Chrome has behind it, but it is coming along quite nicely. So you'll notice up here there is a URL bar where you can type and pick different URLs. These are URLs of spatial fabrics. And we accept both MSF and straight up JSON, and I'll show you what each of them looks like. So this is our home page. Actually, let me come back in here. How do we make that go away? So this is our solar system. It's actually fairly accurate. I can zoom out. I can zoom all the way in. Right now, our movement is actually quite limited to zooming forward and backwards and just twirling around, but we're going to be changing that in the coming weeks to months. I'll just show you a couple little things. Here's a fabric that shows off some of our lighting in here. We have the ability to do directional lighting, and there's a little bit of ambient lighting in here, and there's some, it's not a spotlight, it's a point light in there, so again, not all that super exciting. But actually, you know what, let me show you. We do have an inspector over here, so this shows you what's going on. We got a couple cubes, and we have some lights in here. These are the objects that we've downloaded. These are little console logs that are going on. This is actually the elements, so you'd find this in a web browser inspector. We've got storage over here. There's actually no storage in this particular fabric to see, but this would show you the equivalent of cookies and storage in a browser. But this red line here, that is a fabric. I want to go back to the one that we started with here. This is our opening page. And you'll see here, this is actually 3 fabrics being composed together. And so this entire solar system, which does have, let's see if I can go in here. It does have all the planets in it. Earth system over here, which is both the Earth and the Moon, and our Artemis logo, which are bound in there. That is an actual separate right here. This is separate spatial fabric. And then the Artemis logo itself, which is hard to zoom into given this thing. It's right here. You can kind of see it. You saw it go by. This little guy. That also is a separate spatial fabric. Now, they're all being hosted on our servers, but you could pull them off of any server. And you can see here the parent-child relationship between all the objects and the fabrics that are embedded within inside of them. I showed the video of Dallas-Fort Worth. So this is the Dallas-Fort Worth Airport again, spatial fabric. And this guy, you will be able to, I would say, a couple weeks, you'll be able to actually come in here and walk through here, literally get down to the floor level and just walk on through. And if there are services embedded along the way, you would be able to interact with them. If you were walking in the airport, VPS and GPS would allow you to actually synchronize where you are in the world with the spot you are in the airport. If you visit in VR, you'll be able to teleport there and walk through. And if you're there with VR and AR, you've got someone in their AR and someone in their VR, you'll be able to see each other at the same time. What else do we got in here? This is an example. This particular fabric is one of our little test fabrics that we use for showing you how to build a fabric. I want to point this one out because in the network, this particular spatial fabric is signed here. And so we do have a viewer, and this shows you what we're reading off the spatial fabric. It shows you who owns it. We are able then to use this information to handle our security, to make it possible to share storage information between your organization or within a particular fabric, or more than one fabric that all share the same domain. So it's all kind of familiar if you've ever been in the inspector for browsing. And then I got one other one in here, I think. Nothing exciting. So that's it. So that's our demonstration of the browser. You are able to create your own spatial fabrics, host them on the server, download the browser, point them at your spatial fabric, and load it up. And so before I hand it back to Neil, I do want to point out that this is probably the number one thing I want to point out is the difference between what we have today, which is if you create a 3D asset, you create a GLB file or you create a Gaussian splat or whatever, the question then is how do you deliver that content to the end user? And so what you would typically do now is you're going to build an application around your content, and then you're going to try to convince your users to download your application, right? Or if you're walking around the world and you have a QR code, oh, just download my app or download my app, because you have to embed your content inside of an application right now. That's what the web browser changed, is you didn't have to deliver an application anymore. You could just put information on the internet, and a browser could come and pick it up and safely and securely deliver that content and render that content for you. And that's what metaverse browsing gives you. If you don't really, if you thought we were just pushing the word browser around as a buzzword, it gives you the ability to create content, put it on your own server, and a browser can come, pick it up, handle the delivery of it, and handle the display of it. And we handle so much other stuff. We handle, within the Sneeze browser, we handle the co-presence, the avatars, the audio, all the different things that go around with working with that content. As an application developer, you can focus exclusively on publishing your content, and you don't have to be an expert in networking, or you don't have to be an expert in scaling, or you don't have to worry about the delivery and putting a whole ecosystem around it. And so that's the the most exciting thing, and when you actually get your hands on a browser and you actually download and load up a fabric for the, not download, but when you load up a fabric for the first time, you will feel that experience of browsing, and you'll realize what it is that we're talking about, and why it's why this whole project is so important.
Cool. Yes, Dean deserves the applause, definitely. So that's going to wrap up. Next steps, and I'm just going to get rid of this thing. Everyone is welcome. I mean, we're obviously at the very beginning of a long journey here, and we can't do this by ourselves. So we need participation and feedback. Before we get into that, though, I wanted to, because this is SIGGRAPH, and I'm a graphics person, I was intrigued by the virtual co-presence example, and trying to suddenly realizing that there's things you can do because you have a shared scene graph. And it's been I've been on an interesting personal journey as Dean and Sean and Yin-Chien have had the patience to bring me up to speed on what they're trying to do. When Sean was first talking around virtual co-presence, the fact that how is the person remotely going to see the scene where the real people are? Well, it's a digital twin. Oh, okay. How are people going to do? Oh, it's the shared scene graph. Okay, all these pieces kind of fit together. So this is one interesting to me use case where the guy is sitting in the bar, and that there's a real candle with a real physical light, and it has some kind of Bluetooth transducer in it. So the facility can tell where it is and can place it spatially. And then the remote viewer, the woman looking at the scene through the VR device, that virtual light in the virtual scene can light the environment and the other user, because you can actually have lighting from one service interacting with the geometry and materials on a second service and actually affecting lighting. Now, obviously, that's kind of a trivial example, but I think once people begin to figure out, and also that would have to happen with permission, because normally you don't get access across to other people's data, but these kind of cooperative services, I think, would figure out that kind of model. And this is just the beginning of innovation on how we could actually begin to deliver interesting experiences if we had this kind of basic machinery in place. So what are we taking on? I know this sounds like a super ambitious project, and it is in many ways, but changing the world is never easy. But the good news is we're hardly inventing anything at all. We're reusing almost everything. Web standards, 3D standards, all the good work that W3C is doing, all the good work that the GeoPose and Open Geospatial Consortium are doing. We're leveraging a lot of the work that Khronos is doing, and there are many, many other standards organizations that are going to be needed to make this all work. So this is kind of the prototype, minimum viable product set of pieces that we need. GLTF is an input format. Doesn't have to be the only input format. X3D, USD. We can bring in anything. GLTF is maybe a good place to start. OGC have been doing a lot of work around GeoPose, but there's a lot of work to do on a portable way of an application to find out where it is. Because there are multiple VPS APIs, there's GPS, there's all indoor positioning is an unsolved problem. All these things, we need the standards community to come together to actually create a portable, easily accessible way for the developer to ask, where am I? And tell the spatial fabric, and the spatial fabric will, in return, tell it what services are close to you. The server code that's downloaded into the Sneeze browser is sandboxed WASM. So you can use any language that generates WASM, and of course WASM is an existing, well-proven W3C standard. All the decentralized identification work that W3C is doing, I think this is a great use case for that. On the output side, you don't have to use Inari, but the SNEEZ prototype browser has decided to use Inari, which is a rendering engine API, so you can use any backend rendering engine. I think the first rendering engine is Filament, but it doesn't have to be that. It can be anything that has an Inari interface, which is relatively easy for engine vendors to expose. There's SPIR-V, which is for GPU offload if you're doing inferencing on device or other compute-intensive work. And of course, on the back end, we have well-proven APIs like Vulkan or Metal DX12 on different platforms, and OpenXR, of course, which is what WebXR uses, and the SNEEZ native browser would use the native OpenXR API to do all the XR device stuff. All of that I just mentioned is already existent. We don't have to reinvent any of that. There's some holes and gaps, but sure, we can help those SDOs fill that in. There are a couple of new things, the things in red that Dean has been talking about. The SOM. The SOM is the shared SIGGRAPH. It's not super complicated. SIGGRAPHs, everyone has a SIGGRAPH. The question is how are we going to share it? But that's not a huge problem. RMAP is, I think, it's one of the best ideas. It's how REST should have been designed. There's no existing standard. There's a prototype in open source that RP1 have put in open source, but we need to find a standardization home to make RMAP a proper standard governed under an IP framework by an SDO. So, but that's part of the Metaverse Standards Forum's mission, is to identify these opportunities and to identify a good home for that kind of standardization initiative. So we are early. Thank you for coming today. You'll be able to say that you were here at the beginning of the journey. We were at AWE, we're getting very positive feedback there. We've launched the initiative back in March, so it's only a few weeks. The SNEEZ engine has been open sourced in June, and now with the Artemis browser, which is an RP1 project. And of course, anyone else can build a browser using the SNEEZ engine. We hope that there could be multiple browsers. But we have the Artemis browser now that's using SNEEZ that we can use to prototype and experiment. We're beginning to get some visibility in the industry. Forbes did their AWE roundup, and we got a good mention. I think beginning to see the visibility begin to grow. Of course, again, we're at the beginning of this journey. There is an interesting piece of momentum, though, already growing. That is in academia. The University of Rochester has a Center for Extended Reality. Once they understood what we were trying to do with the Open Metaverse Browser Initiative, they set up a sister organization called the Open Metaverse Academic Alliance, which is specifically for universities to join together to contribute from the academic perspective to help this initiative in place. And I believe they have like 300 universities signing up into that already. And if this is of interest to you, you can start now. If you're an enterprise, you have all the pieces are in place that you can build and deploy spatial fabrics. If you're a device manufacturer, you can begin to look at embedding an engine like SNEEZ or SNEEZ itself to enable your device to access these services as they become available. If you're a web browser vendor, you can put the SNEEZ browser engine in alongside your existing browser engine. It doesn't replace anything, it just complements and adds additional capability. And you can actually begin to compose the 2D browser engines with the 3D browser output and do interesting things that way. If you're a developer, I think there is a real opportunity. The first developers to come to market with tooling, now you could be the WordPress of the metaverse. And if you're a standards body, please help us identify where you can help build out the necessary standards to make this all come into place. There's a bunch of stuff we haven't even mentioned here, like how do you take your personal belongings and personality between different metaverse sites. There's layers and layers of standardization that this is going to need and enable. So, again, if you're interested, a number of things you can do. Join the MSF. Again, the entry level is free, and there's no IP framework. There's not even an NDA. So it's super easy to join. You can explore the details beyond which we've managed to go into today on the Open Metaverse Browser Initiative. On the wiki, there's a whole bunch of information, so please go take a look. You can download and try the Artemis browser, and you can go to the SNEES repo and begin to download, use, and contribute to the open source. So that's it. Thank you very much. Oh my God, we're exactly on time. Oh yes, so these slides and the video will be uploaded hopefully tomorrow, or at least before the end of the week. So,
and you'll find them?
We'll find them on the Metaverse Standards Forum website. Yes, yes. Thank you, Leonard. Yes.
All right. So when Dean was talking about certificate-based security versus, for example, the way it is set up now, what I'm wondering is, so if that's something that you're doing, if it's certificate-based security, and maybe I just don't understand it well enough, but does that mean that Metaverse Standard Forums or SNEES or who would be responsible? Because you said they would have signed certificates. Who would be overseeing that? And that's one question. The second part of that is, if I understand that correctly, and you literally mean, signed certificates for each person creating the meshes or the fabrics, I guess, then how would that scale when you have a gazillion people using this?
I'll stay here. So a standard code signing certificate will work. Well, let me say one thing. You don't have to have a cert, just like you don't have to have an HTTPS website right now. Now, the browser kind of enforces it. If you don't have it, you're going to have to jump through hoops. Are you sure you want to go to that page? Are you sure? So it would definitely behoove people to have a secure website. It would behoove you to have a signed fabric. Anyone with the code signing cert can use that existing one. Anything that works its way through a standard root cert will be recognized. I know that we will be providing something very, very, very affordably, very, very affordably, so that if you're just doing something for your house, right, if you've got a fabric that you want to set up just for your house or just for a little small area, then that's going to be completely feasible. If you're trying to operate this facility here, when you walk through this facility with glasses, you want to know that you're actually communicating with the LA Convention Center, or when you're going through LAX Airport, you want to know that you're communicating with the Convention Center. So even when you're going to a website right now and you're using HTTPS, you do have a certificate behind it that gives you that HTTPS protocol. So it's not that browsers don't use the certificates already, but they still rely on the domain name and cores. Literally, if you're trying to build a domain name and you've got two hosts, like we've got www.rp1.com and dev.rp1.com, browser doesn't normally trust it to. You have to set up complicated cores to get that all to work correctly. Or if you're serving it from a CDN, or God forbid you're trying to get a JavaScript file or some other file from a completely different domain that you don't even own, it gets really, really messy. So in practice, I believe it works pretty well.
Who would be the signing authority?
So, typical, like, we've got a code signing cert. Right now, we get one from Apple, and we get a separate one. Microsoft forces us to get a separate one, and I think Meta forces us to get a separate one. So somehow that does have to change so that you can just get one cert, should do, but
Would it be the same? It would be probably the same authorities that's signing now.
yeah, it should be the same ones that are all signing right now. So anyone who,
It's just a different
Yeah.
certificate.
Yeah, I guess I'm just saying who's overseeing that. Who would be overseeing?
Well, it's the same. It's trusted vendors, right? Like Apple and Google and the rest.
but if
I mean,
I'm going to get
that's not new infrastructure. That's something we don't have to invent. People are issuing certificates
You would just
today.
insist that they use that rather than, like, for the meshes.
do you want to say something?
I think the certificate system gives us more granularity, right? So if you just say, oh, I'm happy for everything to fall under one bucket, they can use one certificate for like one bucket of things, right? You don't, it's like, at the moment, buckets only come in one size. You want to store a marble or the whole bucket, if it's in a different bucket, it's a different story. But with the certificate system, you are able to sign things more specifically, and this gives us more granularity of security. So I don't think it has to go high or lower. You can basically go lower in terms of the granularity you get from your security. Because at the moment, it's very coarse.
Yeah, I understand all this.
Yeah.
I guess maybe I'm not making my question clear enough. What I'm trying to figure out, and maybe this isn't a real question, but what I'm trying to figure out is on who checks all that. Not the person who's signing it or who you're setting up to do it, but like at some point somebody's got to say, oh, we saw that these were signed or these were done before you give them access or permission. Maybe I'm misunderstanding, but that's kind of what I'm asking. How do you know that it's been done and who's going to oversee that? Does that make sense?
So those companies already exist right now. So we're not going to reinvent in this stuff, right?
Right.
So is that a bit?
If they don't exist.
No, they do exist
They
right
do
now.
exist, but not for.
No, they do exist for us. We're just using the same certs. You don't need a brand new cert for the metaverse. It's any cert that you have your root certs that are already built into your
Okay.
browsers and into your operating systems, and then you have the certificate authorities that check to see who your company is. They don't like we took like a month to get one from Apple because they snooped. They want to see your DUNS number. They want to make sure that you are who you say you are. They want to check your billing. They want to see your bylaws. They want to see your literally your state. Corporation, and so that's what they do. That's their job is to say, we put a stamp of approval on here that says we believe that this company is who they say they are, and then they grant you that cert, and then you're good to go. But those already exist, so we're not reinventing any of that stuff.
It already exists for
the internet.
SOM, for the.
They exist for the internet in general, for just general security, and so we're just using the same thing. We're not inventing it.
Okay.
It's already part of the way the internet already works. So we're going to just keep using it,
Got
but we're not doing
Yeah.
right.
Thank you.
Yeah, that's a good question.
Hey, Walter, from OpenXR Working Group. I guess I'm trying to understand, what is your mental model, what is the user model, and also what is your model for what the level of integration with the system platform is? For example, I'm wearing AR glasses, for example. So maybe I can break it into two parts. One is like if we go back to like one of Neil's pictures of the Uber plus the Google Maps plus a thing, who's deciding what appears to the user? Is the user deciding? Because in the browser model, it's a destination model. I go to an address. But in this thing I see here, it looks almost like it's push, where things are pushed to you. And so this is sort of related, it's somewhat related, it's tangentially related to the certificate problem, but it's more like, what is the user permission or user model? That's part one of the question. And the part two of the question is more, depending on, like, I guess let's do part one first, because I think that my question number two might change depending on what you answer.
You did spot a unique thing about the Metaverse browser's composability. Because the web is composable, but the current web, when a web page has multi-origin sources, it's composed by the author of the page. And in our model, the composition is done by the user. So the user actually decides where the feeds are. And whether what they accept in the push is a little bit like the way notifications work on your phone. You can say, don't tell me these things, do tell me these things. So for instance, critical information like there's a traffic jam, right? So they'll override. So the user does choose what they compose with, but they can also set permissions on what they see. In the same way that you have ad blockers. And also there'll be things like age-rated things, for instance, that will also be built in the profile.
Or maybe AI agents will take care of this for me.
I'm gonna augment that.
Right.
So I'm going to augment that a little bit. So if
No pun intended.
Let's take a specific location like this convention center, which is really big. And so this convention center would own the entire property. And if you went to, I'm going to guess, lacc.msf through the browser, you would get just this convention center and anything that this convention center embeds within it. But there will be bigger public spatial fabrics that handle bigger areas. So there might be a Los Angeles spatial fabric that actually owns all of Los Angeles, or an LA County that owns all of LA County, or an even bigger public spatial fabric like the one that RP1 operates, which will cover not only the planet, but the known universe as well. And so when you're walking around the known universe, presumably here on Earth, but if Elon's got his way, maybe even Mars too, we will have the whole thing mapped so that as you walk around the streets and as you pass different stores and as you walk into the convention center, your browser will know exactly where you are. Everything will be geolocated. Now, we won't be the only one. We're happy to compete on an open marketplace with, say, Google or Microsoft or Apple or Meta, who wants to run their own public spatial fabrics too. But your glasses will be tied into presumably a public spatial fabric, which will guide you through the planet. And if you've got VR, you can then escape the planet and go maybe to a galaxy far, far away, and who knows what you're going to find out there. And you will be able to explore. But all that will be mapped by just bigger and bigger and bigger maps. And the maps are all nested inside of each other so that when you're on the planet, yeah, we know generally where everything is on the planet, but we don't know specifically what's going on in the convention center. So the convention center will provide specifically what's going on here, but then the convention center might have a restaurant that knows what's going on in that restaurant, or they might have a backroom facility that's maintained separately from
Okay,
from
so
the public
can I
infrastructure.
ask my part two? Because I think this helps inform my part two. So based on that, I guess, what is the mental model for how you integrate with the platform OS? Like, in what you've described, it almost sounds like the web browser is the OS, it is the window manager, so that's like what I'll call the Chromebook model. Right. And then there is like the traditional like OS model, like there's apps that go on top of iOS or Android, and you install different apps and you switch between them. The way you guys described it, it sounds like the user is effectively in the Metaverse browser the entire time, and maybe there's some interop for other, like I guess these fabrics that are downloadable apps effectively. Is that the right mental model?
I see what you're doing, because you have taken, in the form of a question, that's really astute observation that XR devices work very differently than 2D devices, right? So your phone works on a model of apps that each reside in their own rectangle, and then the user has to pick and choose which apps to download and install on their device, and then they have to pick and choose which apps they want to launch and interact with and switch between. And so you do require an operating system to manage that. And also it's random access, so the user decides, oh, I got to pay a bill right now, I'm going to go to banking, or I want to go watch fancy kitten videos on TikTok or whatever. And so that type of user interface that we're all familiar with and we've grown up with for the last 30 or plus years or so, works wonderful for 2D devices. But for XR devices, especially when you're immersed in the world, they're primarily designed as a browsing instrument, right? So a pair of glasses, to sit there and to have a phone interface on a pair of glasses would be really awkward, just like having an XR interface on a phone would be really awkward. So given that XR devices completely work differently and require different behaviors, it's our belief, collectively I believe, that XR devices will be inherently metaverse browsing devices, that you really will go to a single URL, so to speak, a single fabric that will then guide you through the world, and you will never randomly access URLs. You might get services, but there are things called overlays. So you can turn on an overlay. There could be a cute kitten overlay, so that randomly you just have cute kittens appear somewhere in the world, and that's your choice, right? If you want to turn on that overlay, you can do that. Or if you want an overlay to track airplanes in the sky, or an overlay to do like Yelp reviews. When you're walking down the store, you don't want to be forced Yelp reviews on you, but you might be hungry. You're like, I'm not in LA, I'm in this strange city, where can I find good food? So you turn on the Yelp overlay, and that's your option, and then that will overlay on top of the world. So it's an augmented form of browsing. But yeah,
Yeah,
the
so-
operating system is maybe...
Yeah, I agree with that. I guess what I'm trying to understand is what is the assumptions you're making about what, like, is this the environment to rule them, one rule environment to rule them all, the SOM to rule them all, or is there a coexistence model where saying there's other technologies that would also be able to coexist in an interoperable way? Like, how much of how deep are you imagining you're in the layer stack, basically the layer cake, effectively? Am I asking the question correctly? Maybe I'm not answering.
I think your Chrome OS example is pretty good. So I think initially there will be a coexistence model, because when the Metaverse browser exists and Metaverse exists, many things will not yet be covered. Just like with the web. And I think for a long while, things that are only available in the platform OS will exist there. And just like has happened with the web browser, more and more sort of compute and productivity moved online, but that didn't happen overnight. And so a coexistence model did exist. I also think that in the longer term, the Metaverse browser is essentially a spatial browser. So things which don't need the spatial may continue to exist on the platform OS, but at its full reach, it should be able to absorb everything. Like at full reach, you can Chrome OS, there is no more platform OS. The web OS is, obviously web OS is LG TVs, but the idea is that the platform OS will exist as long as it has a reason to exist. And if things can happen without the web platform OS and goes just into the online OS like Chrome OS, then that will just be, like the market will decide that.
But I think there is a really interesting conversation to be had between all of this that we're talking about here and the multi-app stuff in OpenXR. I think that's a conversation that we need to have, because there are going to be hybrid.
Right.
There are going to be hybrid models, and we haven't.
Well, there's at least a transition period. Right?
Yeah. Well,
So
or yes,
if you believe open is the future of everything.
Yeah.
Right.
Yeah, you can definitely see different use cases for different classes of device, and so we need to have that conversation. I think it will be an interesting conversation to have. Yeah.
Neil, I think he has a question. I had one really quick follow-up question to that.
Yeah, sure.
And then I'll pass it over to you. But so, based on that information, if you said to him that you can also choose to turn things off. For example, let's say I'm not interested in local Ubers or restaurants or whatever. I'll turn that part off. But my question is, if it's this model where I'm not choosing to go to a website, I'm just simply wearing my glasses that are AR glasses, and I'm walking through town, and these things are popping up. So I understand that I can turn some of them off, but the other part of this question is if they're feeding that into glasses that already have these abilities, for example, are they also knowing that I'm there? Like, let's say I walk past restaurants, do they also get that back so they know that I'm in their proximities? Like, for example, if people visit our website, we know certain people visit the website. You can get demographics and stuff. So what if I don't want anybody to know where I am? Do I have to just completely turn my glasses off? Or do you get what I'm asking? Like,
Yeah, sure.
it's kind of more getting into privacy policy, ethics type stuff, but I'm interested in how this is going to be for, like, what if I'm not that secretive, but what if I didn't want someone to know where I was? That's my question.
Very popular question. So when let's say you've got a public map on and you walk past a store, and so the browser says, oh, I know there's a store here, and I'm going to bring that in. So the browser then has to form a connection between your client, your browser, and the store. And so if you were to prevent that from happening, if you were to say, I don't want to be found or I don't want to be known until, you can be told that there's a store there, and you can choose, like if you walk by some random, Quiznos, that doesn't even exist anymore, I don't think, and you say, I don't even want to form that connection, right? So you by default will have it off, so they will never know that you walk by because the browser will never form that connection. You can also pick and choose how you want your identity to be known. So you could also say, no, I don't. I want to see the content there, but I don't want them to know who I am. And I don't want to do anything about me. So, and the content should also be categorized. So the big question we've gotten over and over again is pop-up ads, right? How do we prevent pop-up ads for advertising? And so that will be, every spatial fabric will be self-categorized. But the great thing about having the certificate-based identity is that if people don't play by the rules, their certificates can be known as someone who is not playing by the rules, and the browser can then disable those particular companies.
I think opt into everything.
Yes.
Yeah, I guess I was asking that because of what you said earlier, which is you don't have to pick and choose at every website what you want, so I'm thinking that's kind of the same
Yeah,
thing.
that's why an AI agent is going to be needed.
Yeah.
Because there's literally a million services. There's no way you're going to be able to go tick, tick, no,
Right.
yes, no. You're going to say, you're going to start out saying, don't tell me anything.
Yeah,
and
but
don't
that's
and
the
don't, don't expose my privacy to anybody.
Right,
And
that's-
then you go, okay, I do actually want to know this and that and the other.
No matter how we do it, we're still stuck in that world where we need to be very careful about what's shared on us.
Yeah, right. The security model is actually better than the current web. But there's lots of things to figure out. Yeah.
I think we have time for maybe one more question.
Sure. We can keep going until we get somewhere.
Okay, I guess so.
Praveen from OpenXR as well. So from an end user perspective, when I shut down the Metaverse browser, would the Metaverse continue to exist? At least my instance of Metaverse, would that be an eventual thing to see? Or is that how users should expect to use the Metaverse?
Go for it.
The issue of persistence is still undecided. I think that when your session ends, for all sorts of reasons, there will be some classes of information that you do not want to persist and some classes that you do want to exist. We have not determined which things you do and don't want to exist. Right? I think that the idea of your data presence in the metaverse should be within your control, whichever way you decide. If you want to be off, you should be able to be off. I think that there are things that will appear in the design of the metaverse which are heavily informed by what has gone wrong for the web. I think that the idea, ad blockers are like are the third stage of an arms race between ads and the anonymification of browsers that Safari does by jiggling your thumb, your fingerprint. Fingerprinting is we will learn lessons from how people wanted things to do, and there's a moment because we are starting again to try to design privacy in rather than doing it afterwards. Because the original web model is really, really open, and it was a matter of like honor. It was like for want of a better word, a gentleman's agreement not to just shove ads into people's faces every 4 seconds. But that didn't work in the end. People just did keep running ads, and I think that we will not finish the browser conversation without being informed by what did go wrong on the web.
Right. So I'm thinking not just about the persistence of data, but the logic that modifies the data as well. Mm-hmm. So I'm trying to think whether it makes sense to run the logic on the user's device, or the logic should be running remotely.
Oh.
It can be both. It depends on how the service is run. So in many cases, it could run locally. I mean, there are things that, like when you coordinate, say, a game, where, I go back to my poker example again, where the poker server has to coordinate the activity of the different players of the game, but we would want to run as much possible on the client side just to offload the work from the server. So it really depends on the application, I would believe. I can't say there's a one-size-fits-all where everything has to run in the cloud, but from a timing perspective, when you do run things in the cloud, then it makes it difficult to have a real time, right? So if you're managing real time movement of objects, the more that runs locally, the more proficient that works out.
Yeah, got it.
I mean, Oggy winner. I think this is perfect for the innovations that you guys are doing by running stuff in a private space on device, because you can design the service. So you can design the service. You download the WASM code. You can be making whatever presumption. I know stuff is going to be computed in private, in the sandbox, and just expose the bit that you need. You can design that. You can design the whole pipeline from your sandbox all the way up to the server. Everything is your code. So this is enabling, I think, for privacy, because the security model is better.
Yeah. I was thinking more on how to extend the services model as well.
Yeah, right. That's a rubbish mic. Any other questions? Okay. Thank you, guys. Thank you for coming.